Okay, I will try my best to give you an update on the GR740 ecosystem, the software ecosystem. We felt a need to also try to summarize what's available from Gaisler and a few of our partners to try to give as a complete view as possible of the software ecosystem together with other presentations this afternoon. So I will start with the quick overview, and then I will go in and give some details on these different packages. So what we provide from Gaisler today are tool chains for BERC, Linux, Artems, VxWorks, and Zephyr. Partner software from partners that are presenting today include XNG or Extratum Next Generation from Fentis, PikeOS from Cisco, and VxWorks as well as Symix from Wind River. We also have our own set of bootloader software or system initialization software, which are the commercial products GR Boot and GR Boot Standby, as well as our free open source bootloader creation tool, MakeProm 2. Next to that, we provide also a simulator, tsim3, and also the GR3 debugger. We do compiler work, but these are typically, we distribute them as part of the tool chains for the different operating systems. So first an update on GRMon. So this is a tool that most Leon or Noel 5 users have experience with. So it's a way to debug systems that are based on our IP library, and through, at least for the GR740, this debugging and monitoring of the hardware can be done in a completely non-intrusive way. You don't cause any timing effects on software that's running on the system. In recent years, we've added a graphical user interface. It's extendable through tickle scripting, and we are continuously extending this debugger with, for example, OS awareness, so that you can go in and inspect internals of operating systems, thread awareness, and so on. A little used feature in GRMon is also the support for error injection, where you can use diagnostic interfaces to inject errors while it's running on target hardware. Recent news when it comes to GRMon is that we have added support for C and C++ language debugging, and this support is available in the graphical user interface version of GRMon. It makes sense to make use of the different views and panels to show this. So you have the feature list here on the slide. And this is something that is now immediately available in the 3.3 release. So we don't depend on GDB or other external solutions except for Eclipse frameworks to perform or provide this function. But GDB debugging is, of course, still supported. Moving to our simulators, then there's a lot of talk about simulators today. What we provide is the tsim3 simulator. Our focus is not on performance, but on accuracy. So we try to be precise in modeling the hardware behavior. We're not really competing with the solutions that try to provide real-time or better than real-time simulation. tsim supports 3 different operational modes. So you have the standalone front end, so you basically interact with it like you do with the debugger. You can use it as a library together with your application, or you can attach to a tsim instance through GDB. Down at the lower part of the slide, you can see what we currently support in the GR740, and the big new item is that we are finally going to introduce a space-wide router model in the simulator, and this was actually something that we initially developed for our microcontroller, because of course a microcontroller must include a SpaceWire router. There will be separate presentations about this today. We've already seen CIMICs being presented. We see this as a very positive thing, that we have actually a really wide and strong ecosystem when it comes to simulators that are competing with our products, but modeling our ASIC devices. So to mention them, the big complete candidates for when it comes to simulation is the Therma TEMU 2 and 3. We have the Wind River CIMICs, and we also have the CARI LASIM simulator. I think we've seen performance figures from that one today, and it's a really fast simulator. Unfortunately, CARI is not here to present this today. Also worth mentioning here is, although it has limited support for our full system on chip devices, the QEMU support for Spark, it's there, and we have made good use of that ourselves, and that's also a completely open source solution. Moving on to the target software instead, and I will try to summarize this. I've mentioned that we have GR Boot. It's a flight system software suite that targets Leon-based system. So what GR Boot does, it initializes the system, it can perform self-test, and then it can perform application loading as well. This has been developed in the context of ESA developments, and we implement the Savoir flight computer initialization sequence. So this can make a lot of sense within ESA projects, because there's familiarity from the agency when it comes to reviewing the bootloader sequence and so on. In addition to the self-testing and application loading, there are also hooks so that you can plug in a standby mode. So instead of moving to your application software loading, you can go into standby mode and you can accept commands. We expose a POS service over SpaceWire, and that allows you to, for example, upload patches to your application software. So that standby software is a separate product that we provide. GR Boot is one software product, and this standby software is an add-on to that. And recent additions to this is that we have a GR Boot BSP for the GR740. We did not have that at the time of the last GR740 user day. Moving on to operating systems. We provide VxWorks support. Gaisler provides the architectural port. Wind River does not support the Spark architecture directly, so you would need a source code license from Wind River and the architectural port from us. And then you can get support for VxWorks from both companies, both Gaisler and Wind River. This is, of course, a mature product, and we see users of this on both sides of the Atlantic, perhaps with some weight on the US side when it comes to VxWorks users, while in Europe we have traditionally been Artems users. One trend we're seeing is certainly increased interest in Linux. So we heard that from in the presentation from the Mohammed bin Rashid Space Institute or Space Center, that they implemented their application, and they when they interacted with the mass memory, they wanted to mount that on the Linux, and it was extra effort to interface this via traditional interfaces. And we see the same thing for single board computers, that new users expect to boot Linux. They want to have their NAND flash available as something they mount, and they load their userland from that NAND flash. So that's certainly happening. And we have Earlier in this year, we have made significant improvements to our Linux environment. We provided something that was called Linux Build, which was a custom front end that used Buildroot as a subcomponent. Now we have introduced something new because the Buildroot interface is good enough. So we actually just use that as is, and we package this in a way that we call the Leon Buildroot. And you grab that, you have a Buildroot environment, and we package Linux long-term stable releases within that. For use of Linux on the 740 or other Leon devices, you can also grab the Linux kernel from upstream from kernel.org. That usually works just fine. Then for European space and also with significant use in the US, the RTEM support. We provide our own RTEMS toolchains called RCC, which we base on upstream RTEMS. So the big news again since last time that we spoke at the user day is the release of RTEMS 5.1 stable, and I believe also RTEMS 5.2 has been released now. There are some differences compared to what you get from the RTEMS project and what we provide. We try to upstream all of our patches, but for example, our toolchain is based on GCC 10 instead of earlier versions coming from the RTEMS project. Some news that has happened, we have relicensed the contributions that Gaisler has made over the years to the RTEMS projects in support of moving away from this GPL variant of a license. So we see it as a very positive thing that the RTEMS project is moving to a BSD 2-clause license. Finally, on the toolchain and operating side, we have our BEAR-C compiler that we are keeping up to date. It includes now a 740 BSP, and we also have several, let's say, bare metal level software drivers. With the more complex architectures that we build, we do believe that people are going to move away from writing in BEAR-C, but this I think is still our most widely used toolchain. On the lighter side of software environments, we have also recently added support for the Zephyr real-time operating system. This is the newest addition that we have to the operating system. This is something that is now, I believe, handled by the Linux Foundation, initially introduced by Intel as an Internet of Things operating system. There's a very wide and active community here. We are doing work on it for Spark and GR740. You will also see that there is work being done on this, for example, to support the NG Ultra. So there is a lot of interest in Zephyr, at least from the component vendor side. There will be presentations both from Fentis and from Cisco on their hypervisor solutions. We can say that we see also a very strong trend here with interest in running things in containers or wanting to apply things like Docker in space applications. So with the GR740, we support para virtualization. You likely need to, if you want to run a full operating system as a guest under a hypervisor, you need to do para virtualization. But as we have seen in presentations earlier here today, these are software techniques or architectures that are being applied by our customers. For more information on the GR740 software system or software ecosystem, I want to highlight that we do have a fair amount of information available on our website. We have a software overview page. You go to Gaisler.com, click Product Software Overview. Important page is also our software lifecycle documents, where you can actually find out and have expectations on how long we will support software packages. The space industry may have very long development times, and this is something that needs to be tracked. We also have other collateral in the form of technical notes and so on. The software ecosystem for the GR740 will continue to be extended, and this also is helped by us introducing the GR765 that will be introduced by by my colleague Fabio later today. Since we maintain software compatibility between the different Leon versions, now when we increase efforts to complement or extend the software ecosystem for the later generation Leon devices, it will also benefit the existing ones. So we have one national activity under ESDP, funded by the Swedish National Space Agency, that will lead to improvements of GR boot and also improvements to Linux, actually, as well as TSIM3 extensions. And all of this will both benefit the 765, which is the later generation product, and also the GR740. I also want to extend a hand here. We are trying actively to improve and extend the GR740 software ecosystem by collaborating with partners. So when it comes to collaborations where we can provide support with the GR740 component or be part of qualification activities or provide software tools, then please come and talk to us. We're also planning an improved visibility for partners on our website. We do have solutions where we can provide remote access to hardware that can be difficult to get your hands on otherwise. So if you yourself have a software package or you have a partner where you would like to see that software package available on the 740, please don't hesitate to ask. To conclude, the major new items that we have recently or since the last GR740 use day is the C and C++ language debugging support in the graphical user interface of GRMon. There have been extensions to TSIM3. There is a new RCC, RTEMS toolchain release from us, continuously new improvements and releases of VxWorks. And we have made big changes in our Linux support. That move to, let's say, native build root is a big improvement in user experience. We try to keep the toolchain between all of these operating systems the same to achieve a commonality there. I've mentioned the standby extensions to GR boot and also the improvements or addition of Zephyr. So I would like to take this opportunity to thank you for your attention, and also again thanks to the partners that have joined in partnerships with us and that are collaborating to improve the software experience for GR740 users. So thank you for your attention.